be pretty, will I be rich? Hear what she say to me. Que sera, sera, whatever will be, will be. The future's not ours to see. Que sera, sera. When I was just a little girl, I asked my mother, what will I be? Will I be pretty? Will I be rich? Hear what she say to me. Que sera, sera, whatever will be, will be. The future's not ours to see. Que sera, sera. When I was just a little girl, I asked my mother, what will I be? Will I be pretty? Will I be rich? Hear what she say to me. Que sera, sera, whatever will be, will be. The future's not ours to see. Que sera, sera. When I was just a little girl, I asked my mother, what will I be? Will I be pretty? Will I be rich? Hear what she say to me. Que sera, sera, whatever will be, will be. The future's not ours to see. Que sera, sera. When I was just a little girl, I asked my mother, what will I be? Will I be pretty? Will I be rich? Hear what she say to me. Que sera, sera, whatever will be, will be. The future's not ours to see. Que sera, sera. When I was just a little girl, I asked my mother, what will I be? Will I be pretty? Will I be rich? Hear what she say to me. Que sera, sera, whatever will be, will be. The future's not ours to see. Que sera, sera. When I was just a little girl, I asked my mother, what will I be? Will I be pretty? Will I be rich? Hear what she say to me. Que sera, sera, whatever will be, will be. The future's not ours to see. Que sera, sera. When I was just a little girl, I asked my mother, what will I be? Will I be pretty? Will I be rich? Hear what she say to me. Que sera, sera, whatever will be, will be. The future's not ours to see. Que sera, sera. When I was just a little girl, I asked my mother, what will I be? Will I be pretty? Will I be rich? Hear what she say to me. Que sera, sera, whatever will be, will be. The future's not ours to see. Que sera, sera. When I was just a little girl, I asked my mother, what will I be? Will I be pretty? Will I be rich? Hear what she say to me. Que sera, sera, whatever will be, will be. The future's not ours to see. Que sera, sera. When I was just a little girl, I asked my mother, what will I be? Will I be pretty? Will I be rich? Hear what she say to me. Que sera, sera, whatever will be, will be. The future's not ours to see. Que sera, sera. When I was just a little girl, I asked my mother, what will I be? Will I be pretty? Will I be rich? Hear what she said to me. Que sera, sera, whatever will be. The future's not ours to see. Que sera, sera. When I was just a little girl, I asked my mother, what will I be? Will I be pretty? Will I be rich? Hear what she said to me. Que sera, sera, whatever will be. The future's not ours to see. Que sera, sera. When I was just a little girl, I asked my mother, what will I be? Will I be pretty? Will I be rich? Hear what she said to me. Que sera, sera, whatever will be. The future's not ours to see. Que sera, sera. When I was just a little girl, I asked my mother, what will I be? Will I be pretty? Will I be rich? Hear what she said to me. Que sera, sera, whatever will be. The future's not ours to see. Que sera, sera. When I was just a little girl, I asked my mother, what will I be? Will I be pretty? Will I be rich? Hear what she said to me. Que sera, sera, whatever will be. The future's not ours to see. Que sera, sera. When I was just a little girl, I asked my mother, what will I be? Will I be pretty? Will I be rich? Hear what she said to me. Que sera, sera, whatever will be. The future's not ours to see. Que sera, sera. When I was just a little girl, I asked my mother, what will I be? Will I be pretty? Will I be rich? Hear what she said to me. Que sera, sera, whatever will be. The future's not ours to see. Que sera, sera. When I was just a little girl, I asked my mother, what will I be? Will I be pretty? Will I be rich? Hear what she said to me. Que sera, sera, whatever will be. The future's not ours to see. Que sera, sera. When I was just a little girl, I asked my mother, what will I be? Will I be pretty? Will I be rich? Hear what she said to me. Que sera, sera, whatever will be. The future's not ours to see. Que sera, sera. When I was just a little girl, I asked my mother, what will I be? Will I be pretty? Will I be rich? Hear what she said to me. Que sera, sera, whatever will be. The future's not ours to see. Que sera, sera. When I was just a little girl, I asked my mother, what will I be? Will I be pretty? Will I be rich? Hear what she said to me. Que sera, sera, whatever will be. The future's not ours to see. Que sera, sera. When I was just a little.
Hi, sorry for letting you wait a second or two. That was not wanted. Hi, how are you doing? Oh, already two people. Wow. Today is my lucky day. Mhm. I checked you. Hello, Marco. I see that you are here. Mhm. That's that made me feel like somebody who is checking everything. The master of puppet. Hello to everybody that is coming to me, and thank you for coming by. Today we are talking about Python in the sense of class and methods. So another exercise that is very near the complex number. It's about this time real number. So we are going to have a little fun, but before, let me enjoy this cup of coffee. In Germany, the coffee is awful? No, I would say it's not. It's just another type. It's just very long and very light. So, if you are here, um, as I said, we were going to enjoy classes in Python, and I learn a lot. It's about also magic methods. That's the name. And I'm going to speak about my adventures because, as you know, I'm trying to enroll to a course of Python that will be paid from the Agentur for Arbeit. The little detail or problem of everything is that, well, um, everything is going to be paid from the von Agentur for Arbeit. But what is not clear is that it seems they forget or lost, or I don't know what has happened to my um, it seems that they lost my paper in which I asked them, yes, I really would like to participate into this course, please let me know. And it seems that the letter from me went lost. I sent two letters, one to the agency, and they complained because it seems there is not all the documents that they need. And now the firm has not got all the documents that they need. So this document seems to get lost somewhere in the air. And well, if you are here, and I can check if you are here. Ha ha ha. Ooh, ooh, ooh. I'm waiting for more people to come, and I'm checking if I can already rate somebody because yes, I feel a little bit guilty that I didn't rate Mimo back. He's a very loyal guy. Memo. Sorry. One of the awful thing of me is that I don't remember the name of people. So is he online? Also offline. Okay. Mm. Ooh, today is the 5th of May. My father turned how many years? I don't know. 69. He turned 69. He turns 69 today. So, yeah. Yeah, if we still have had a relationship, happy birthday, father, but we don't. He's still alive, as far as I know, but we don't speak much to each other. Okay. So let's go to this fantastic stuff. It's about real numbers. A rational number is defined as a quotient of two integers, a and b, called the numerator and denominator respectively, where b is not equal to 0. Note that mathematically the denominator can be 0, otherwise you got problem. However, in many implementation of rational number you will find the denominator is able to be 0, with behavior similar to a positive or negative infinite in floating point numbers. Infinity. Okay, those cases, the denominator and numerator generally still can both be 0 at once. The absolute value r of rational number r divided by b is equal to absolute value a divided by absolute value b. The sum of two rational number r1 and r2 is blanch. The difference of two rational number is that one. The product multiplication of two rational numbers is blank. Dividing a rational number by another is if a is 2 is not 0. Otherwise it would be this part 0 and yeah, it goes to the infinity. Exponential of a rational number to a negative integer power, truc. Exponential of rational number to a negative integer power, blanch, where m is equal to absolute value n. Exponential of rational number r to a real floating point number x is the quotient, blanch, which is a real number. Exponentiation of real number x of a rational number r is this part, where root p and q is the qth root of p. Implement the following operation: addition, subtraction, multiplication, and division of two rational numbers. Absolute value exponential of a given rational number to integer power, exponentation of a given rational number to a real floating point power, exponential of a real number to a rational number. And then there is a quote by say that if you find 30 divided by 60, for example, you should reduce them to 1/2. In order to reduce that, The reduction form of a rational number should be in standard form. The denominator should always be a positive integer. If the denominator with a negative integer is present, multiply both the numerator and denominator by 1. And that's the problem, because it's not true. You are not going to do that. For example, 3 divided by minus 4 is reduced to minus 3 divided 4, but you don't multiply both of them by minus 1, you multiply just one. Yeah, sorry, I forgot. You can multiply both of them by minus 1 in this sense that this one would be 4 and this one minus 3. But if you do that here, it's not going to work in the same way. You need, if both of them are negative, you need to do minus 1 that multiply the numerator, and then the norm would be without this minus 1. If you do that, I guess there will be problems. I try. Yes, some of the stuff is not going to work, and you have, for example, 2 minus instead and then having a plus. So if you do this, then it works. Okay, good. In order to reduce, you need also this ZCD is called, that you have, if you have, for example, 12 divided by 8, you should calculate the GCD. It would be 4, so you can divide everything by 4 and you can reduce it, which is why we are going to do that as soon as possible in the constructor. In here we import the method math that we are going to use afterwards, I hope. We have the class rational, and here there is the constructor with numerator and denominator. The CD, it would be done thanks to this method that is going to be found in math, in the import method math. So you use the method GCD from the import method math with numerator and denominator. So you have, if you had in the example before, 12 and 8, which is 12 and 8 are as ZCD, you will have 4 as result. And you can divide, as they did here, everything by 4, which I'm going to copy in here. Everything can be divided by 4, and you reduce your number. If everything is negative, so if you have minus 3 divided by minus 4, as we said before, you keep this minus for the numerator, and the denominator would be just 4, because you need to keep your minus, but your minus should be before the numerator. So that was the first part of it. Sorry for showing my face. I want to know how many people are here. Nobody Nobody. Okay, and how long am I streaming? Okay. So this is the typical operation when we want to how may I say, to confront two numbers, and we say that these two numbers are equal. This is the magic method IC. If two numbers are equal, the numerator of this number is equal to the numerator of the other number, and at the same time must be that the numerators should be equal. So how to represent it? It would go like self numerator divided by self denominator. Add. Add, it means you add two, for example, two rational numbers. So you add 1 divide into 2, 1/2, plus 1/3. That's what you do. And actually what you do at the end of the day is multiply 2 by 3, which is the second part. You multiply both the denominator. And for the numerator, the new numerator, you have 1/6. 1/6. And in here you need to sum. What you do in here? What you do in here, you have 1/2 plus 1/3. In here for 1/2, you would be 3 plus, you have 1/3, so you have 2. And you sum it, you say 5. Always have a lot of fear to make mistakes because I'm not an English native speaker. I speak other languages, and then sometimes math goes to hell. So now you have this sum, which is represented here. You have the other denominator by multiplied by self number, so you have your 3 multiplied by 1 plus other number, it's 1, multiplied by self-denominator 2, and you have 5 at the end. You can use the same logic with subtraction. The only thing that you subtract, the way to calculate the denominator is the same. The way to calculate the two part that subtracts one the other is the same. How to multiply? It's very easy. You may multiply both of the numerator, one with each other, and the denominator also. So if you have, for example, 2/3 multiplied by multiplied by 1/2. I'm going to be very slow right now. So you would have to delete the two, one with the other, and the result would be 1/3. And what you do actually is really multiply the self number with the other number numerator, and the same for the numerator. And reducing does this thing for you. It eliminates the two that we eliminate with our calculation. So this part should be always done, and it's better to do inside the constructor. Through division, that's the problem. There are a little bit more cases, and the cases are if you have the self number and the other numerator, the self numerator and the other numerator negative, or they are both positive, there is a way to build the rational number. If you want to build an object, you write the name of the class and their parameters. So the rational we have defined as rational here, and we defined a new, I write here, but I could write also somewhere else. Don't consider where I write. Rational, a new rational would be defined like this. New rational is rational, and then I have to put something in here, a numerator and denominator. And guess what? What I did when I returned something is really, if you look at it, I don't say the name because I return automatically, so it's like this. And I have this in here, I create the numerator, and here the denominator. And numer. This is the platform that I use. In fact, if you have a look, I have this comma here. So the numerator would be done by self number multiply my power in this situation. But coming back, if I don't make everywhere a mess. Coming back to division, I return a rational number that is done like this. The numerator is, I multiply the numerator of self with the numerator of the other, and I calculate it with ABS, because I need to have a positive number. Divide one negative number by another negative number is a positive number. If I divide two positive numbers, I will obtain a positive number. The same for the nom. I calculate absolute value, and this is how to create it. Now I remove this one because it creates just problem. If it's not the case, if something is negative, as we said before, the negative part should be every time in the numerator written. So that's the thing. The absolute value is actually very doable with the method absolute. So the numerator would be the absolute value of the self numerator, and the same for the numerator. Power is something very interesting, because you can rise to a number, to an integer, or to a rational number. That's the problem. If the type of power is an integer and the power is greater than 0, you can just use this way to create another rational object, which is this part that is numerator and this part is denominator. If not, if the power is negative, you need to invert the function, invert your rational number. So you use the denominator here, and you use the power as positive, because you can use absolute value. The same for the other part, for the numerator. If the power is 0, you can return a new rational number which has a base of 0 and also power which has a base like 1, sorry, and wait a second please, sorry, you can create a new rational number which has a numerator like 0 and denominator. I'm sorry. You can create a new rational number which has a numerator that has value 1 and denominator 1, because if we elevate everything you want, so for example for power 0, I don't know how to write it, for multiply, I guess, multiply, elevate to a power 0, you will have 1 as a result. And 1 is like 1 divide 1, okay? You can write it like a fraction, 1 divide 1. And that's the way I write 1. That's the way I write 1 in here. Numerator is 1, denominator is 1, and everybody is happy. There is something that is air power. It's basically another case which I couldn't use in here, in which we have a base that can be a number, but we raise this number, which can be 1, 2, 3, 4, 94. We rise to a power that is represented by a rational number. So you can write your new object defined like this. You can return, and you can use the math method. You can use, the math dictionary with the method power, with a base that is done by this method at the beginning, and how to raise it, and the number to raise it would be self number divided by denominator. You can run the test, and it works. It was a battle yesterday, but I'm here to fight. I can lose, but I basically here to fight without be violent, of course. And that's the long story about Python today. Sorry if I made any mistakes, sorry if I was not precise every time. I'm here to learn. So if you give me any suggestions, I will be happy to try to apply it with my human limitation. I'm not perfect at all by any means. So. Okay, Memo is not online for all the week, or am I wrong? I can be wrong. I should be online. Maybe. Okay, I'm probably making a mistake. Okay, doesn't matter. For tomorrow and for the weekend, I would like to solve another exercise. If I do it, I'm happy. If I don't, I'm sorry. Because this week I made 2 exercises in one day, which makes me happy, and also I'm happy because I was afraid to be too late and not to follow the schedule, so on, be too much in delay. I know for sure that I will not be able to finish all this course before the other course will start, but it doesn't matter, I can finish it afterwards. What was important to me was keep going with the same timing, at least one exercise per day, and understanding it and repeating it with you, what I have learned, what I cannot understand. So it's like self-mentoring. Because if I can explain something, it means that I have reached a deeper understanding. Instructions. Write a function to solve alpha alphametics puzzles. Alphametic is a puzzle where letters in words are replaced with numbers. For example, sand plus more money equal money. Sand plus more is equal to money. Replace these with valid number gives 95671085 plus, and you can find this result 10,652. This is correct because every letter is replaced by a different number, and words translate into number that make a valid number. Each letter must represent a different digit, and the leading digit of multi-digit numbers must be not 0. Write a function to solve all alphametic puzzles. The problem is that it's not going to be open in here, so I don't know how can I show you. No idea why. The online editor is not available for this exercise, so this exercise locally and submit it via the CLI. Click the arrow. Click the arrow to the right for more informations. Okay. So yeah, I will try. And there are thousand more people in here in this fantastic world of Python. Every time there is somebody new, which makes me happy, but a little bit worried at the same time. A lot of people that can compete with me and win. Oh, I'm so afraid to lose. No, I don't care. Losing means learning to me. So I'm not that afraid. The only trouble I have right now is just you are very few people, and I need to rate. I need to rate to somebody. I wanna rate somebody. Na 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 me. I wanna rate somebody, and there is just one person, two persons, two people. Nee, 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 nee. Who may I rate? Who may I rate? Yeah, let's see. Who is in Python day? Mm. Mm. Rigo. Kathleen. Ooh, somebody who is new. Maybe you will appreciate it. I want to read to somebody. See you during the next week. I will be very available. I hope so. So see you. Bye bye.